Hello friends, viewers, listeners, and my dear students. How are you? I'm sure you are all doing great. And this is our third online class. So in the last class, we have already started with different types of chemical reactions. We have completed combination, we have completed decomposition and different type of decomposition. We have also completed exothermic and endothermic. And today we'll be starting with a very interesting chemical reaction, that is displacement reaction. So it is displacement reaction. Displacement reaction. So what do you mean by displacement reaction? The name itself says it all. So here displacing is going to take place. So the definition for displacement reaction is going to be higher elements displaces less reactive elements. Higher reactive elements displaces less reactive elements. So my dear students, this is the definition for displacement reaction. Here the stronger ones are going to outsmart the less reactive, the weaker one, in a simple word. So if I'll give you a chemical reaction for this one. Let's take copper sulfate and let's take zinc. So the products that we'll get here is zinc sulfate and copper. So for our listeners who are hearing the voice clip, copper sulfate, the chemical formula is CuSO4, and zinc, the formula is Zn, and the products we get zinc sulfate, that is ZnSO4, and copper. So here what do you get to see is copper sulfate and zinc, they are reacting together. On the reaction, what we get to see is zinc, being the higher reactive element, displaces copper and takes its position. So on the product, what we are seeing is zinc takes the position for copper, and now copper is left all alone here. But how will you know that zinc is highly reactive than copper? So for that, we have to know the reactivity series. And for class 10, the reactivity series is given in your third chapter, metals and non-metals, and which you have to learn by any means, because we'll be referring to the reactivity series for any kind of chemical reaction, and especially for displacement reaction, to check and to see which one is highly reactive and which one is weaker, the weaker elements. So not to waste time, if you flip back the pages and go to third chapter, it will take a long time. So I'll write the reactivity series in the board, as well as I'll speak out verbally, so you can write it down. So the reactive series, it starts from potassium. So we have potassium, we have sodium, we have calcium, we have magnesium, we have aluminum, we have zinc, we have iron, we have lead, L-E-A-D, lead, we have hydrogen, we have copper, we have mercury, we have silver, And the last one we have here is gold. So whatever I have said just now is a reactivity series, and it is in the order of decreasing order. So the top one here is the highly reactive element here, and it goes down, and the last one that we see here is gold, which is the less reactive element. So now they have their rank. When we say potassium, that's the first position, that's the highly reactive. So let's go back to the previous equation which I gave you, which was copper sulfate reacting with zinc, giving zinc sulfate and copper. Here, zinc was able to displace copper because zinc is more powerful, let's say, to make it clear, to make it simple. So zinc is more higher in position than copper. That's why zinc was able to displace copper. So if we look at this reactive series, zinc is in the 6th position, whereas if we go down, copper is much low below zinc. So this, from here, it is very clear that zinc is reactive than the copper. So this is how displacement reaction works. The highly reactive element displaces the less reactive element. Another example, let me give you copper sulfate and Fe. Fe is a chemical symbol for iron. Iron, Fe. So what will be the result if copper sulfate reacts with iron? Let's check from the reactive series which one is more reactive, either iron or copper. Let's see. Let's look here, students. So iron comes below zinc, and if we go down, copper is 3 steps below iron. So that means iron is more powerful than copper. So here iron displaces copper, and copper is left all alone here. So now the second kind of confirmation or observation that we'll see in displacement reaction is change in color. Change in color. So copper sulfate, it is bluish in color. It is blue in color. It is blue in color. So now copper sulfate, blue in color. When zinc reacts with copper sulfate, then the color will change. The color will change to colorless. Since zinc was more reactive, even we can see that the color has been changed. So color changing is also one example for displacement reaction. Now in the second example for displacement reaction, copper sulfate, as we all know now, it is blue in color. Here we will get to see that after reacting with iron, this will change to green. A pale green in color, a pale green in color. So this is how displacement reaction works. And to know the reactivity series is very important. So students, please write it down. I have said it out verbally for our listeners as well. And for those who are watching, please write this one. In your textbook, you'll find in the 3rd chapter, I'm repeating again, it will be in metals and non-metals. Clear? I know all of you are smart. You will be able to memorize this reactivity series. But for some students who will have a little bit difficulty in keeping this reactivity series or chemical names in mind, I'll give you a simple trick. I'll give you a sentence so that you will be able to refer the chemical names with the sentence which I'll be giving you right now. But remember, the sentence which I'm going to give you is not a part of your syllabus. It's just to let you remember this reactivity series. Clear? So it'll go like this. Now we all know P is potassium, so I'll give you this sentence. Please, okay. P for potassium, so please stop. That means sodium for stop. Calling. C is calcium, So now please stop calling me a 0. Instead, like him or her, so that girls and boys both can refer. So him or her. Call me smart So the same thing here. The last one we're ending with goal. So just to let you remember, you can either use girl or guy. For girls, you can use guy. For guys, you can use girl. So this is a simple sentence. Please stop calling me a 0. Instead, like him, call me a smart girl. So you can remember this sentence for some of you. For some of you who will have a little bit difficulty in remembering the chemical name. So it will be P for potassium. So please, it goes on. So you can remember the reactivity series in this way. And whatever I have written this one down just now, it is called reactivity series. Okay, students, reactivity series. Reactivity series. So now we all know that potassium is the highly reactive and it goes down to gold, the least reactive. Okay, now if you are done with this one, before we go to the next type of reaction, now if in exam, if a question comes in this way, if a question comes, zinc sulfate reacts with copper, what will be the result? Now, zinc and the opponent is copper. So who is the more stronger one? Just now we have learned that zinc is more stronger than copper. So now in this case, will copper be able to displace zinc? No, since copper is less reactive than copper. So in this case, if you are asked in exam, if you are asked the question in an opposite way, then you can just write no reaction, which means there will be no change in color. The color will remain the same, colorless, no change in color. Clear? So students, we are done with the displacement reaction. The next type of reaction would be this double displacement reaction. Clear? Double displacement reaction. Double displacement reaction. So what happens in will you get to see in double displacement reaction? Now you have an idea about displacement reaction. It is where the highly reactive replaces the less reactive. So it is related, but now here two displacement is going to take place because the name here itself says double. So first I'll write the definition for you. Two compounds exchange their ions. Two compounds exchange their ions to form a new compound. So in a simple term, now two exchange will be taking place. I'll give you a chemical, I'll write a chemical reaction for this and I'll explain as well. The chemical reaction for this would be, so this will be silver nitrate, students, AgNO3. Ag is a chemical symbol for silver, silver nitrate Okay. And then this NaCl is a sodium chloride. So the result we'll get is silver chloride and sodium nitrite. So student, you can write this chemical reaction, but I will explain. Now what we are getting to see here is first we have silver nitrite. This is one compound. This is another compound. So altogether we have two compounds coming together. And now what happens is they exchange their ion. So silver takes this, now sodium takes this. So it's the same thing, but in the product we're getting to see they have exchanged their ion. In other words, double displacement has taken place. So in this, the simple example to keep in mind, because science, if we give example, you learn in that way. So I'll give an example. I want every one of you to close your eyes and imagine just, let's say, two person, okay? Two person coming, 2%, and whatever cars you want to imagine, you can imagine. So 2% may be a girl or a boy, whatever you can imagine. So 2%, they are coming in a car. So let's name one person Ramu. Let's name other person Shamu. Clear? Ramu and Shamu, they are both coming on the other side of the road. Ramu is coming from the left side, and then Shamu is coming from the right side. And then the interesting thing is Ramu has a green car. Clear? Ramu has a green car, and then Shamu has orange car. Now they are coming. They are coming very close. They are about to reach. Okay, so now they are very close and they have met each other. So now what happens is they have a discussion. So we'll say that now chemical reaction is taking place, in other words. Clear? So after the discussion, Ramu, who had the green car, took Shamu's orange car, and Shamu, who had orange car, took Ramu's green car. So in other words, they just exchanged their car. Clear? So same here. Now what we are getting to see is this A and this N. So now when they are coming together and when the reaction has taken place, what we are getting to see is they have exchanged their ions. They have exchanged their ions. And if you are clear with the concept is very important, my dear students. So concept, you please keep in mind. So now the first reaction is over, but the second condition that you have to remember for this double displacement reaction is, here you will get a, I'll simply write, you'll get a PPT. What is PPT? PPT is a precipitation, okay? PPT is a precipitation. In this type of reaction, the other thing is you will get a precipitation as a result. And what is precipitation? Precipitation is, say, suppose you are reacting a solid particle with a water. So everything will not be melted and there will be some solid particles left. Those solid remaining are called PPT. In other words, it can be insoluble particle. So precipitation, insoluble particles. So we'll get one insoluble particles here, and and the other one we'll get here would be liquid. Clear? So now another condition for this reaction would be we have two compounds. Two compounds, both will be in aqueous solution. Two compounds, both will be in aqueous solution, AQ. Aqueous is, we write in a chemical reaction, we just show them with AQ. Clear? AQ. A like in apple, Q like in queen. Clear? So what is aqueous solution? I'll repeat it again. It is a solution mixed with water. Clear? Involving water. Now, the second example I'll give you for this double displacement reaction, let's take barium chloride, BaCl2 for the listeners. BaCl2, barium chloride, reacts with sodium sulfate, Na2SO4, sodium sulfate. So now students, just have a look on this equation. You can also write it down, barium chloride, BaCl2, and sodium sulfate, Na2SO4. So what will be the result for this reaction? This reaction, no doubt from here you know that there is two compounds, and both I have said it will be in aqueous solution. That means they are in liquid form. So what will be the result? Here you will see a double displacement taking place. So we'll do this one together. Now we have barium sulfate. So just an exchange. Now sodium takes this chlorine. So we have sodium chloride. So done, very simple. This is another example. So this will be in the form of white precipitation. That means the solute remaining. Clear? White PPT. Okay. So students, I'm sure you are clear with the displacement reaction. I will not repeat it again, but please write down the chemical reaction. I've given two chemical reactions and the condition. The condition here where the two compounds exchange their ions and the reactants should be in an aqueous form, and the result you will get in a PPT form. So please note all the important stuff for this double displacement reaction. Well, so types of reaction will be, it's over. The next important topic we will start is redox reaction. Redox reaction. Okay, my dear students, our next topic would be redox reaction. Redox reaction. And under this topic, we will study oxidation, oxidation reaction. We will study reduction reaction, reduction reaction. We will study oxidizing agent, oxidizing agent. And the last one for this redox reaction will study reducing agent. Reducing agent. Okay, this is the main topic that we're going to study. So under this, let me repeat: oxidation, reduction, oxidizing, and reducing agent. So redox reaction, the definition is very simple. Redox is derived from both this oxidation and reduction. Re for this reduction. Okay, I'm sorry, Red, okay? Red. Red comes from this reduction. Clear? It's related, right? See, students, redox. Redox is ReDOX. So this one is from this reduction. And OX is from the oxidation reaction. Clear? So red is from reduction, ox is from oxidation. So redox reaction, the definition is the reaction in which oxidation and reduction reaction takes place simultaneously. Now if I just say like that, now you might be confused. Yes. So I will explain everything step by step so that you will get the concept clearly. And to know this redox reaction, first we have to know the oxidation reaction. Clear? To know this redox reaction, first we have to know the oxidation reaction. Oxidation reaction. So what is oxidation reaction? The reaction where there is an addition of oxygen. Students, the reaction in which there is an addition of oxygen. You can say addition of oxygen or gain of oxygen. The second point will be removal of hydrogen. Clear? So we have the first point, addition of oxygen. The second is removal of hydrogen. And the third one is removal of electrons. Which, the third point, this very point you'll study more details in class 11. In your textbook, they have mentioned more about this first point. So we'll focus more on the first point, that is addition of oxygen here. So I have given three main points for oxidation: addition of oxygen, removal of hydrogen, removal of electrons. So let me give you an example here. Magnesium plus oxygen, we get magnesium oxide, MgO. Magnesium, and this is oxygen. Why we write this, the single oxygen atom, why do we write O2? I have already explained in the first class. Clear? We get magnesium oxide. So simply now what we're getting to see is there is an addition of oxygen, right? It was just Mg, but now on reacting with oxygen, we get magnesium oxide. So this type of reaction where we get to see an addition of O, which is oxygen, is known as oxidation reaction. Clear, my dear students? Okay, now I'll give you another example here. The same thing which we have done before. Carbon and oxygen giving carbon dioxide. Even here, what we are getting to see is there is an addition of oxygen here in the reactant. So this is all about oxidation reaction. Now, reduction reaction is just the opposite of oxidation reaction. Clear? Reduction reaction is just the opposite of oxidation reaction. So I'll list the points for reduction reaction as well here. Reduction reaction. So what did I say? I said reduction reaction is just the opposite of oxidation reaction. Clear? So now here we get to see that there is an addition of oxygen. So now here it will be a removal of oxygen. Now it makes sense, right, students? See, oxidation and reduction, they are opposite. So the first point, addition of oxygen under the oxidation. So for reduction, it will be removal of oxygen. Addition, removal. Now here there is a removal of hydrogen. So it will be a addition or gain of hydrogen. The same thing goes for the third point. Now, removal of electron for oxidation. So for reduction, it will be gain of electrons. Clear, my dear students? So these are the three important points for oxidation and reduction. And like oxidation, I'll give you a chemical reaction. Example for reduction reaction. I'll give you a simple chemical equation where you can use the equation for further reaction, which you'll be dealing even in the second chapter, third chapter, fourth chapter as well. Clear? So shall I wrap this one, students? The next, whatever I'm going to write will be an example for reduction reaction. Okay. So example for reduction, example for reduction reaction. CuO, which means Cu is copper, so and this O means oxygen, so it is cupric oxide, okay? Cupric oxide. CuPric oxide, cupric oxide and H2, hydrogen gas. So now reduction means removal of oxygen. So here we see copper and oxygen together. So now we have copper here and we have water here. So this is a very simple example, a chemical equation for reduction reaction. Now see, here we get to see that there is a removal of oxygen, cupric oxide, but in the products now we get to see only copper. That means already oxygen has been removed. Clear? So student, please keep this equation, write this down, and you practice the chemical equation as well. So chemical types of reaction or any chemical equation, we have to go step by step. That's why I'm not rushing. So for today, please be clear with this reduction and oxidation reaction. And in the next class, I will continue with the redox reaction and also effect of oxidation reactions, which are very important as well as very practical, because we get to see every day in our life, starting from kitchen till and even in our surroundings. Clear? So please continue with the regular studies. Class 10 students, this is very important, and chemistry or physics or any portion bio, you need regular practice. Clear? So students, do your regular studies. We'll continue with redox reaction more and examples in the next class. Thank you.